So myself and Gabe actually work together. We run ads reliable systems, pretty reliable systems. I don't think anyone's seen us go down. We really like failing and nobody noticing. And that's a little bit about what we want to talk to you about today. So we're going to use gRPC as an example. We're going to show you some C++ coding snippets, and we're going to show you what we do to them and what kind of questions we ask ourselves to build more reliable services. So when our developers come and they want to do something new, or we want to build or extend the systems and services, these are the kind of things we ask ourselves before we start building them out, and what kind of subtle, small changes we make to the code and how we run it to make it work better. So you kind of have some rules. And they're also the outline of our talk. So the first one there is everything is secretly a stack. So although you might have one component that's talking to some other things, the other things you're talking to could also have components they're also talking to. So everything secretly is actually a stack. The second part there is sharing is caring. So a little bit about load and how we spread it out, and how you don't want to actually have one part of your component taking, or one part of your service taking all of the load. Next part is fail early. I'll go into more details on that, but that's basically a little bit about how failing early is better than failing late, and what kind of things you can do to make that work better, even though it doesn't sound like it's the right thing to do. Next, degrade gracefully, don't guess. This is probably one of the most important parts. So you don't want to be finding out how you degrade when something has exploded or gone wrong. You want to find it out early, you want to have plans, and you want to make particular decisions, and you want to make those decisions up front. 5, measure all the things. So measured gets fixed. If you're not measuring it, you don't know. So we'll talk about a little bit about what you can do to help give you insights into the stack. Best effort isn't. So this will be our rapid fire round at the end, where myself and Gabe will go through some of the obvious but not so obvious ways in which people say this will definitely make your system work better, but maybe not. And when we say the rules, they're really more like guidelines. So your mileage may vary. Most of this is about how you think about it and how you put it together, so that your stack ends up looking like that when everything falls apart. You can make some plans up front to make that work better for you. So allow me to introduce our guidelines into as serving system. We're going to take an example from the gRPC side, and we're going to use C++ coding snippets. I want to give you guys a few minutes to get in and get seats. Feel free to come up the middle. Can the last person in the door close it? Okay, cool. So this is our stack. It looks relatively straightforward. You have a greeter service. You say hello to the greeter. So the client will send you an RPC. It'll say, hello, whoever you are, back. This is taken verbatim from the gRPC website. So this is like the sample, simple case, the little tutorial we put up. We're going to add a translator backend to this, and we're going to talk about what we do as SREs, what kind of changes or what kind of things we think about making changes to make it work better. So first thing you're going to need to know about is what the actual class looks like. So you have a status returned, you say hello, you give it a name you want a greeting to be sent to. The greeting there is actually, I don't know if anyone knows the language. If you do, come up to us later and you can let me know whether anyone recognizes it. It's really quite simple, it's really quite straightforward. You set a prefix, prefix is whatever you want your default to be. It returns back, says status OK. So if you want to have a look at the code samples, they're all there on the site as well. Straightforward, simple, easy. Okay. So in order to understand what we're putting together, we're going to talk to you about protocol buffers. Hands up who knows protocol buffers. OK, so smattering of people. Anyone who doesn't know protocol buffers, don't worry. We're going to talk about them. So you can get more information on developer.google.com protocol. It's language independent. It's basically a way of putting the business logic together. If you used XML and other things, you might have come across it before. But it allows us to put the business logic into one place, and then regardless of what code we use to create the service or the system, it'll generate some helper code for us and make all of that easier. So the basic one we have here is the translator service. So this is me showing you what the API kind of looks like for what that translator backend is going to do. The numbers on them are called tags, and gRPC uses this to build the helper code. So it'll create something called a stub, which you're going to call for that service. So the first part there to see is service translator, and you see it says RPC translator. You send a translation request, and it returns a translation reply. And those are messages. So if you look at the step up from that where it says message translation request, that's basically what it is. It's a string with a message, so whatever that is, hello. What language you want to use, in this case, for just saying, give me English, as an example. The little 2 slashes are to give a comment. So what you want to do when you're writing these or when you're creating them yourselves is give hints to your users about what kind of thing they should put in there. It's always handy to give like a little note to say, this kind of thing is what I'm expecting. And the final one there is a type. And there we're using an enum. And one of the things to watch out for when you create this is the first answer, the first one of the enum is going to be the default used. So you want to kind of put something in there that would work for all cases, or be maybe the unknown case or something else. But you want to have a fairly good think about that before you put something in. But that's what it looks like at the start. And then over time, things change. And the reason particle buffers are so useful is that will actually change and update with you. So this is what it looks like after things have been going a while. So you had that rude version of a translation that you're looking for. We actually decided, maybe we don't want a rude version. Maybe we'll call it slang or something else that's a little bit less picky. So you might have to make changes for adding new features, or you might make changes because there's some business reason, or there's some case for changing your product to do something, and this helps you do that. So we also mark it with the deprecated equals true, and that means you'll get when you go to build, you'll get a warning to say this field is deprecated, don't use it. The other thing that changes is you can see the translation request. It's actually got a little bit more interesting. Probably we extended the translator backend, and now it's able to do kind of more clever or give you more options on what kind of location you want for the English translation or the German. Do you want the French version from Switzerland, or do you want the German version from Switzerland? Which one do you want for the Swiss speakers? So we'll have a locale that will be more exact, and we give an example there as well about that. We're also moving from the language, which people could send you. We're going to call that reserved. And the reason we do that is to prevent future business. We don't want somebody reusing that field. And also, we want to tell people that we might be making changes to the API. We might be dropping that field. We might not be supporting it anymore. But you may have binaries out there running in your production system that still use it. So until you can actually get everything off it, you're going to put it in there. If something goes wrong, you can end up with things not being able to parse the protocol buffer and everything crashing horribly, or not being able to return something. So we would give you warnings of don't reuse and never update a type of a field. Like stick to whatever it is. If you need to change the type, create a new field. So we're all good in protocol buffers. Okay, moving on. So it's here to help. It'll get you there. Okay, so everything is a stack. The client asks it to say hello, it gives a name, it gives the locale, and the server asks the translator backend for the localization string, and returns the hello string. So this is pretty much what it's going to look like. Little arrows sending RPCs over and back. Everything we run as ad serving is basically binaries with RPCs coming in and other RPCs going out. So ultimately, all of our systems break down to this. No matter what kind of service you're running, that's kind of a standard thing you're going to get everywhere. So putting the little messages in so you can see what's going on. If you're not familiar with it, say hello, Fred. We ask for it in Spanish. It sends a translation down the stack to the translator backend. Translator says, translate that to hola. Here you go. Sends it back up. And then you say hello, Fred, back to your client. So it is a toy example, but just to make it more obvious what's going on. Okay, so everything is a stack. What does that translator look like? That translator service that we're now using, that we're adding into our code, into our stack, is probably got other clients. And so kind of things that might be using a translator service might be the emailer, it might be a help system, and that translator that they're talking to, because we're all using the same protocol to see what's going on, that's probably a blob. We don't know what's in there. All of those systems could be complex systems in themselves as well. So you might see the emailer has all sorts of components. It may have database, it may have other things going on. If that translator system is that important to all these services and has all these services talking to it, it needs to be as resilient as possible. It needs to be as robust as possible. And it can have its own kind of components and everything going on behind it where it needs to be able to return something useful if someone asks for a translation. So if one of those backends goes bad, so let's say our translator DB goes offline, it shouldn't cause the greeter or the email or anything else to crash. All of those should be robust enough to stay up, and they shouldn't stop working just because one of the components in the translator stack goes down. So we're going to check out the code now just for simply adding the translator to the greeter. So it's in C++, this little code snippet, and we'll show you what kind of changes we make to it. So there's our stack. We allocate a client context. So that has all of the client object has the entire information about the RPC state. You're going to see I'm going to color code this so it lines up with our diagram. So we allocate the response and request to fill in. So you'll recognize that from the protocol buffer translator.proto file you were looking at earlier. So it has the translation request, translation reply. We set our message, say hello. We set the location we want from the request from the client, stick that in there. The gRPC library is going to take care of all the communication, marshalling and unmarshalling of that request as it goes through. So we're going to invoke the method on the stub. So remember I talked about the stub, so that's that service, translation, RPC, that creates a stub. So we forward it on, and that sends it on to the server. And that looks like this. So you're going to get a status back to tell you what's happened with it. We're passing it our context that we've created, so that's going to put everything in together. We give it the translation request, what we're looking for, and it will fill in the translation reply. Then we're going to check the response, check the status, and handle the request. So if all okay, replace that prefix hello with whatever the translation service came back with, and then let's use that. It's that simple, right? Not too confusing. A couple of lines of code, and we're ready to rock and roll. So taking the original example we had pulled off the gRPC site, you can now see the code that we've actually added to add that translator backend. So you create the context, allocate a request and reply, fill the details in, hand it off to gRPC, get back our answer, set it up. So you can actually see links to the example code down the bottom there if you guys want to follow along or have a look at it on the actual websites. So how does the greeter process pick a translator process to send an RPC to? So most likely you're not going to have one greeter or one translator, and you'll have 2 machines in the whole world, and that will be it. So one of the machines has to go down for repairs. Sorry, you don't get any hellos. No more greeting service today. Come back tomorrow, or we're going to go out for the weekend and have beers. We'll see you Monday. So you're going to need some way to send or get requests from one to the other, and how's that going to fit together, and how's that going to work? So that's step 2, which is sharing is caring. I'll hand off to my partner in crime, Gabe.
Hi. So sharing is caring is the topic, and the usual phrase that everybody uses is load balancing. And of course, that's exactly what we mean by it. What we actually mean by it is less load balancing, we mean load spreading. Everybody calls it load balancing, so we'll use that term here as well. There are 3 things that we want to achieve. One is redundancy, as Grainne mentioned. If one of them goes down, we just use a different one. We want to improve our utilization somewhat, like the traditional thing is some kind of hot and cold failover system. We prefer doing hot-hot because otherwise you're wasting half your capacity or however much. Speaking of capacity, this allows us to manage our capacity more easily, of course. Like bigger servers is kind of harder to do than more servers. And managing latency as well, but latency is kind of part of capacity in this sense. It's part of your SLA, I assume. You can trade redundancy, utilization, and capacity against each other to some degree until you're down to like one server, at which point you get it may as well fall over. So load balancing itself, there's a variety of things to consider. So we won't talk about the front bit there, which is sort of how does traffic come to your service in the first place from the internet. That's not a trivial problem, but basically you only get to use DNS because that's what the internet uses to find you. There's a couple of tricky questions to answer there, and none of them are particularly exciting, and none of them are gRPC specific anyway. There's a couple of mechanisms that can try to help you to guess, like given a query from a name server, or how many servers are behind that. Is this a big ISP? Is this Google's 8.8.8.8? Like how many people would be using that? A couple of things that might help you there. But fundamentally, all of this comes into just the HTTP service, which then decides what you're actually going to talk to. However, if you look at the middle thing there, all of this looks exactly the same if you just zoom in. So let's talk about this bit. It's as if we right-shifted. You have some kind of front end, and they need to find your backend, and then they need to talk to your backend. There's the one step that I'm going to skip here, which is how to what technical mechanism you use to find the backend. It's probably going to back onto DNS somehow. There are some ways of managing that. gRPC has a way to sort of give you hints there. But the more interesting thing is what strategy do you use? Like, never mind how you deliver the actual information, probably DNS, but what information do you want to deliver? What strategy do you use to spread your queries across those backends? If you want to get started, use round robin. We actually like round robin. When in doubt, always use round robin. You have a random initial choice, and then you just cycle through round and round. Easy, straightforward. In the worst case, one of the tasks is bad, or X tasks out of them are bad, you get X out of N of the traffic that are bad. Okay, that's the worst thing that can happen. It's not ideal for resource users, not ideal for that failure mode, but it's easy to reason about. It's not a bad start. It's fine. One thing it doesn't do is care about sort of given a request, is this an expensive request? So you can understand it when you get paged at 6 a.m. That's nice. And the failure mode is probably not catastrophic, won't give you the best results. Thing to solve the capacity issue is using the least loaded one, where you have some kind of metric of sort of which of my backends has the fewest requests outstanding, which of them has the least work to do. That works kind of better, but has a worse failure mode. That's your trade-off. If you have a central coordinator that sends that one has no traffic, everybody will pile onto that, and you've got this thundering herd running it over. If you do not have a central coordinator, the clients don't know about each other, so they don't have the big picture, have the whole picture of who's getting how many requests, how expensive are they, and so on. And finally, if one of the backends is just serving errors, that might be very quick and cheap. So suddenly you're sending everything to the bad backend. So this one has more problematic failure modes. So you can put them together in a sense of weighted round robin, where you have some kind of definition of cost, where you know that this query is going to be expensive, or this query has been this expensive, this backend is now this busy for some unit that the backends kind of report, so that you know which one is the least loaded, and then you round robin between those based on your weighting function. That gives you great results, but all of the components need to care about the cost, everything needs to work, and it's really tricky to reason about. Given a request, where does it go? Well, it becomes harder to predict. The other thing is, you then have this thing where all of the frontends talk to all of the backends. I said round robin is easy to reason about. I'm not sure that's particularly easy to reason about. You have the setup overhead where every frontend needs to connect to the backend, make sure that it has a connection. That may have gone away. You may have TCP timeouts to any of these. It will need a little bit of CPU and memory to keep them around. You may have a little bit of network stuff to keep, the connection alive and so on. That adds up. And finally, if you get a query of death coming in, because every frontend talks to every backend, every frontend has the ability to take down every single backend for a catastrophic failure across everything. So maybe we don't need that. Maybe each of these frontends only needs to know 3 or 4 of the backends and not all 12 of them. So we can do that kind of subset addressing. That's terrible in that diagram. They're drawn together to imply some kind of shared failure domain. They can be on the same switch. Well, if that switch goes down, all of those frontends now have 0 backends instead of the others. It could be the same power supply, it could be the same air conditioning unit, it could be the same position under the leaky roof when it rains, whatever. So we spread things out a little bit. So instead, like the front-end one always talks to back-end one of each of the groups. That's actually exactly the same thing as above, as the previous slide, just grouped differently. It has the exact same problem. If one group of servers goes down because of one of the clients, all of the clients lose all of their backends. We want to spread things out a bit differently. We can do total random assignment. That sounds great, but usually works out horribly unbalanced. I generated that layout with $random in my shell. The blue backends each have only one incoming connection, and the red one there has 6. So that one's probably going to get overloaded quite rapidly. So we spread things out differently, and nothing is highlighted here because there is nothing to highlight. This is actually spread out evenly. Each frontend has 3 outbound connections, each backend has 3 inbound connections. And we do this by not actually being random. Each of the frontend groups uses the same seed for its random number generator. So the top one uses seed 1, literally. The second one uses seed 2. The third one uses seed 3, so that each of those generates the same order. And then within those, they say, well, I am server 1 of my group. I use the first. Whoops. I use the first quarter. I am server 2. I use the second, and so on. This is what we call a deterministic shuffle. It's still pseudo-random. You still get the random spread that not every set of backend is shared by the same set of frontends, but you get an even distribution of the load.
So now that we have the greeter, we have a backend, we've added the translator, we're able to send RPCs between them, where we have a pretty good spread across them so they don't have kind of a shared failure domain. What next can we do? We're probably going to use something like round robin. We'll avoid least loaded because we want to be cheap if there's failures. So how do we make it reliable? And the misnomer here is fail early, which sounds counterintuitive to why you'd want to, what you'd actually want to do. Surely you don't want to actually fail. But it turns out you should just embrace it. This is our stack we've been working with so far, having a look again. How long should we wait if we set a deadline for the backend? How long do we wait in general?
Half the SLA.
So if you have an SLA, that's great. You can say half the SLA. By default, what do you reckon we wait? How long should the default deadline be? Or what does gRPC give you as a default deadline? Could be. So 1 second. So we could set everything to 1 second and assume. Yeah, there's all sorts of things we could do. So oftentimes, as an SRE, I'm asked, yeah, but what should I set it to? Give me a rule of thumb. Give me a number I can set my things to, and everything will work. And the answer is it'll always depend. So how long are you willing to wait for the RPC to finish, right? So we talked a little bit about, some people mentioned SLOs. Some people say you could set you can make a judgment call and say 1 second. By default, gRPC will do forever, where forever is the largest int in the implementation of whatever you're using. So it can't give you a good deadline. It can't magically work that out for you. You're going to need to sit down and think about it and be deliberate. So you're going to need to think about what kind of questions you need to ask yourself to figure out what should I be setting my deadline to. So some of the questions I typically ask myself is, what's the end-to-end latency of the whole system? So I don't actually control what's in that translator backend. I don't know how many layers into the stack it has or anything else that's going on with it. So I kind of have to make a little bit of guesswork and a little bit about, what does it mean to me? How long do I expect it to take? Do I have any contract with that backend to say, we'll reply by this time? So your end-to-end latency of your whole system, for setting a deadline, so the greeter to the translator, it should be higher than your SLO, right? You want to be able to go by your SLO. So if you say, I'll come back in 200 milliseconds, and you set 400 milliseconds, it's probably not a bad thing to do. It should be lower than your client timeout. If your client has already gone, I don't care, I'm out of here, and you're still hanging around waiting for it to finish or get information back, that's not too useful either. But you need to be able to make some rough calculations. So the SRE book actually has some chapters on embracing risk. So if you don't have an SLO for your services or systems, now is a good time to sit down and kind of think about those things. Which RPC calls can be made in serial and which one in parallel? Okay, how much information do you need before you send out to those backends? So if I'm the translator, I might, that translator DB, getting a response from that might take a long time. Calling it to Google might go out over the internet, God knows where, to which data center, where in the world before it comes back to me. What kind of latency can I expect with that? So I need to look at what kind of things I'll do in parallel and what I'll do serially. If I'm the greeter, I just have the translator backend. So I have to send it, and then I have to wait. So you can think about these things as you work through. If the translator backend fails, should I continue to wait for it until it fails, until I time out? So we'll talk about that in a little bit more detail up next. But you kind of want to be thinking about what things you can do in parallel and what kind of things you can do if you have to wait for that backend. So can we do something useful? Or is there other things that are going on that we can be doing? Do we have a default we could use? So you've seen already, we've talked about having this default prefix that we're already using. So if the translator backend doesn't come back, we can still say hello as a greeting. Maybe the translator, the Google Translate, is an expensive query. Maybe that DB is an expensive query. You could cache that, and you could have that on hand. So if that takes longer than you're willing to wait, you can send back a cache result. You can also continue to wait for that in spite of the fact that you could have replied to the greeter. You could wait for another more expensive translation to come back and cache it and reuse it. So your system tail latency gets better, but you're having to make some of these decisions and think about it pretty hard before you do this. So you need, as engineers, to be able to understand the service, to be able to make informed decisions about it. And you want to think about it up front. Like, as I said before, it's very easy to get started. You can put something together, it'll work, everything looks fine. But if you're not thinking about how it fails or how long you want to wait for things, you're going to end up in a sticky situation later when something goes wrong. So how do you set the deadlines? So I'm just going to show you a little bit in the code. We have our usual greeter translator. So we create the context as before, but this time we're going to include a deadline. So what does that look like to include a deadline? So we take the greeter context we set before, take the system clock now. I'm going to take a flag value for translator deadline, so how long am I willing to wait? Add those two together, and then I'm going to set deadline. And it's as simple as that. So it's not very complicated. It's really straightforward and simple to do. I'm using a flag for that deadline. Any ideas? I'm not hard coding it. And the reason I chose a flag rather than hard coding it is if the translator service suddenly gets slow, say they've done a release or something and it's had a regression and it now takes twice as long, if I need to adjust the deadline for my users, I want to be able to do that fast. I don't want to have to cherry pick to change the default deadline, then canary, then push it out. If you're a global service, you and your users do not want to be waiting that long for that. So I stick a flag in, which means something goes wrong, I can mitigate it really quickly, and then at our leisure, we can do a cherry pick, do a change, or maybe even be able to get the translator rolled back or something else. But right now, I've mitigated it for my users, who are my clients for the greeter, and everything else continues as if nothing has gone wrong. So you will not see this failure, which is kind of the way we like to fail. So you set the flag and move on. What else can we do? We're going to set wait for ready false. So this means that if the translator is not there at all, we will start up, we will take requests, and we will respond with our default reply. We're not going to wait for the latency to time out. We're not going to sit there saying, I'll wait for, that whole second for what I set my deadline to until it comes back. And then I already knew that I wasn't going to be able to reply with anything. So I'm going to set wait for ready false. By default, it's usually set to false, but it's something you should definitely make a decision about. If the translator was your only way of that service working and it was critical and you had no way of mitigating it, you might choose to set it to true. You might say, actually, if it's not there, wait, just build them up and see. Maybe we'll be able to do something else. That would be the kind of thing you might do if sending the wrong response would be dangerous or poisonous. So reasonably small changes, and it gets us where we need to go. And so you allocate the response, you fill in the request, you invoke the services before, and then you check the status comes back. So we set the stub for the translator, check status and response. If I'm the translator, one of the things I can do to help improve the situation where maybe something's waiting for me is to actually propagate the remaining deadline. So the greeter will say, I'll wait a second for you. You pass it to the translator. The translator can actually get that from the context that you've now passed, and it can propagate it down the stack. So what we do to do that is actually to do from server context. We're going to copy it over. So before we send to that translation DB, which may take a long time, we'd like to let it know how long we're willing to wait for a response to come back. So we'll copy it across, and we'll set the greeter context in there. And that will copy everything apart from the wait for ready. And the reason for that is because we want you to make a deliberate choice about whether, for the translator DB is actually critical or not. So if you don't set it, you'll get a default. You should actually be making decisions about what you particularly want it to be. Then the same thing comes back. You get a status, the stub to the translator DB, whatever you're using, you get your response back. But it's really important to think about what parts of your system are critical and which aren't, and which ones you can mitigate and how you can mitigate it, and what you can do for your users so there's nothing to see. So how does that look when we actually fit it into the code? So we add the deadline, and we don't wait if the backend isn't available. So we replace that line on the left-hand side with a small change. So they're small, simple changes. They're straightforward, they're easy to do, and they build a lot of reliability into your service. So they make your life easier. gRPC takes care of all of the things in the background for you as before. Same thing, let's look at it with the translator. How do we change that? So we replace the same line again. This time, for the translator, we're passing the greeter context, so it gets the deadline, it gets the remaining deadline it has left. And we make a small change further down just because of the way that C++ works, so don't forget to do that. So that's how you set the deadline. If you look at the instructions or you read through the gRPC documentation on the site, we talk about a number of places where you can set things. So you have your proto file, which gives you the information about it. You have a service config, neither of which is actually anywhere you set the deadline. The deadline's just in the API. So if you want to give hints to people who are using your service and say, how long should they consider waiting for you to come back, you can put something in your service config. That's currently not wired into anything, though. So there's more functionality coming to that, but coming soon. It's not there yet. So we can set up, we can get it running, we can share deadlines, we can avoid things like cascading failures by passing our deadline on down. It gets exciting if you have a service building up a lot of requests, so while it's waiting to talk to something. So if you have a critical backend, you get more and more requests over time. What do you do? So in some way, you need to also consider how you're going to degrade, or what you're going to do to kind of shed some of those requests as they're coming in if there's nothing you can do. So if you don't set your deadline, wait forever. Deadlines in the client API. A little bit about deadlines, TLDR. Make an informed choice. Understand how the service is fitting together. And particularly, if you're the translator backend, that emailer that's talking to you might have a different set kind of processing time that you need than if the greeter's talking to you. The greeter might be super fast. The email or the helper system might be super long, and you're going to have to balance that. So understand whether you have edge cases or what kind of things aren't covered by deadlines, like if you're using streaming RPCs. If you're a client, wait until the result's no longer useful. Like we talked about before, I might reply back to the client and say, here's a translation, but I'm still going to wait for that client database to come back with something so I can cache it. If I'm the service, you should specify the longest deadline you can technically support. So the service config is good for that, to give a hint to people how long they can expect to wait. So if you're something like the database and you tell it, drop this table, I don't want it anymore, giving a hint back to the user to say, that can take up to an hour. So it lets them know they should wait an hour before they retry. And you can let them know what the retry behavior is. Like, is it dangerous for them to drop it twice? Do you have people who create 6 or 7 things because they're still waiting for the first response to come back to tell them you've created the table for them? So you can give hints to your users and help them understand that better. But you should specify the longest default deadline that you can technically support. If the backend is known to be unavailable, don't wait. Move on. But what do we do instead? So like I said, we're going to degrade. We're going to have to figure out some way of dropping that. So don't guess. We should plan this ahead and in advance. If you degrade by throwing your service on the floor, some services do, that can be something that you might want to do. Maybe it's actually super dangerous if you respond badly. But you should think about, most likely you can do something useful. So you want to think about options and alternatives to protect the system or to help your users. So now that we have the greeter, it can find and send RPCs to the translator. It's got its round robin. We set a suitable deadline. It's tolerant to failures of the backend. So if the backend is down, it will still be able to do something. It will return a useful result. How do we make the greeter more reliable? How many flights requests can you support at a time? So you're going to use up resources as you hold on to a load of requests as they're going. So if you're getting a lot of load, what does that look like? You might want to say you might want to return a 503 or something else. You might want to go a little bit faster. You might want to back signal some back pressure to push traffic away from you if you're not healthy. But you need some way to be cheaper for processing and to have some way of measuring that to know what's happening so that you can actually fix it. So like we said before, if you're not measuring, you won't know what's broken and you won't be able to take action to fix it. So how much work is needed for a failed request? If when you fail, it's a lot more heavy for you to process a request, guess what? Everything gets worse. So if you're under heavy load and heavy load causes you to take longer, and then something fails or you get errors or deadlines because things are under pressure and you're not getting through the RPCs as quickly as you need to, everything's going to get way worse. So another thing to think about is how much health does your service need to do something useful? I run ad serving systems, and I can tell you that at any point in time, some part of it is broken, and I would not want to send traffic there. Always. So there's always parts of your service that are going to be degraded or in some way you don't want to be using. We don't have to use all of them all the time. We have options and reliability for taking care of that, or for moving traffic elsewhere, or for stopping traffic going certain places. But if healthy for me was all the service 100% healthy with low latency, there's no way we'd ever be reliable. Can users still get useful results if some or all the system backends fail? So you always want to have some sort of cheap alternative that you can do. You want to answer yes to that question, and you want to be thinking about how to answer yes. So if you have a critical dependency, you can either change the system design or you can change the code. So we change the code, we have the prefix. The prefix is always there to say hello, some sort of universal greeting. We can always send that out. So everything else failing, the greeter can still do something for the client. Or you can change the service in some way to change kind of what options you have. You might actually say, we'll have a cheap translator that we'll have on site, but we'll have a more expensive translation. So if it's up, we'll do better. If it's not, we'll do something cheap. How does the server behave under heavy load? This is probably one of the best ones to actually spend some time thinking about and working on. You want to figure out what resource limits you hit first. And it might not be the one you think it is. It could be file descriptors. Then what do? Do you have a way of figuring that out? Do you know what your users are sending you or what kind of queries they're getting? And what happens when you're kind of processing some of those or what else is going on? So until you get data, until you're actually loading up your service, you're not going to be aware of those things. So what does that look like for us? Okay, let's kill some stuff. Yay, translator front end. It's there, but everything else in the back end is dead. Now what do we do? So if you get a query of death, if you're the translator service, the emailer system is sending you stuff that causes all your backends to die. Great. You still want the translator to be useful to people, but you need to be in some way able to drop requests that you're getting that are going to cause you to get overloaded because other things are not functioning. So what can the translator do if it doesn't respond? If you've low capacity or a data center has gone down and you don't have that backend anymore. Steps 1, 2, and 3 that we've talked about before won't really change. But you can expire early before you do a lot of processing work. So now that we have that deadline, we can use it. So if greeter context is canceled, so if it's not, we can do stuff. If it is, we move on straight away. So that can get canceled by the gRPC system because something is timed out on the wire before you even saw it. Or it can get canceled by the greeter saying, actually, I'm not interested in that result anymore, don't send it to me. And you want to check that before you do a lot of heavy processing. Make sense? Or you can do something for extremely short deadlines. So say you're heavily overloaded, and by the time you take something off your queue to look at, there's very little left. You can return some sort of partial response rather than doing a lot of heavy load to one of your backends that may or may not be there. So for instance, you might look and say, I'll set some threshold. You can set a flag and say, if there's this much time left on it, give some sort of partial response. And you can mark things in gRPC. You can set a status to say, hey, I'm going to give you less results than I'd like to give you. I'm in some sort of degraded mode. You can tell it's a partial result. Here's the best I have at the moment. I'll have better later if you try back again. But you can look at some of the status codes. So if you look on the GitHub site, you'll see we have status codes. And it talks about certain ones that are reserved for the gRPC system, but other ones you can add yourself in your application layer and make some changes. So you can have a certain amount of time left. You can do something lesser. So if I'm the greeter, there's some things I can do there as well. So 1 and 2 is the same. 3, set the deadline. Have the translator set the context. Check the call status and handle the response. So we can say if everything is OK, go ahead, else. And this is where you want to do something that's useful and cheap. And useful and cheap is usually to log. So one of the things you see there is glog. It's really handy if you're using C++ or writing in C++. We're going to log an error every n. So there I'm saying, I had this kind of error this many times already, and here's something about it. So that might be something where we actually log and say, I sent this request, and it caused, I got partial results or I got bad results. So that might be telling you, actually, that request is taking out one of the backends for the translator. Whoops. But very obviously, if you are measuring it or logging it in some way, you're able to tell that and you're able to debug easier. So it makes your life easier at 6 p.m. on a Friday when things start to go wrong. You're able to see some data about it. You're able to see how broken it is. You typically want to not do this synchronously, because you're not going to send your reply until after you've done the log for whatever you're doing in this case. So you want to make that really cheap. You don't want to be sending it to another service or another system that's catching when you're doing logging. And you would prefer not to do it synchronously. It's going to be very heavy, so that you have to wait till you finish that before you can send the reply to the greeter. Because you could run out of deadline, right? Not all the deadlines in gRPC are when you're actually doing something. Like, you can be using a deadline when you're doing other processing. So if that's expensive to log some sort of error or tell people all of these things went wrong, you want to watch out for that. You want to make it cheap and have some other way of catching more detail or getting more detail. So how does the code change? So again, same kind of code as before with all our additional steps. So the actual difference we're making is just to add a couple of lines. So every change we've shown you so far, and just to repeat, they're all super simple changes to make. They're not heavy. They don't require you to have in-depth understanding of templating in C++. They're just reasonably small, simple changes to make it more reliable.
Hi, Grainne.
Hi, Gabe.
Can I ask you a question?
Sure.
How do you say hello in Irish?
So what just happened there? This is where we ask the question, can we ask a question before we ask the question? So one of the things that gRPC gives you is a way of doing inline health check. It's not useful for everything. You don't want to use it this way typically. We've already put a lot of effort into having deadlines, having some sort of mitigation, having some sort of cheap response. If you ask the translator, can I ask you a question? And then ask the question, you're still going to be in the same place of having to handle a bad response or no response. The fact that you've checked just means you have twice as much traffic going on before you actually get your response. So if you're going to ask, just ask and handle it with mitigations. There are reasons for why we have this. I don't know if anyone can think of a reason. If it's expensive, you should still go ahead with it. If it's expensive, you should let them decide how they want to handle it. Yep, so this is kind of one of the other things where we have, like, you will have to make your own decisions. I mean, if it is super expensive and you decide to, your mileage may vary, but you need to be thinking about it and make a decision. We say load balancing, so anything that requires global state. So if you are load balancing between 2 clusters and you need global state, you want to be able to send like a heartbeat to say, does that cluster have like 10% of the tasks available or 100% of the tasks available? Can I tell about capacity I have in that location? So we might have a use for it in that context. In this context, you're kind of belt and braces. You're not actually adding a whole lot of value, and you can double the amount of effort you're doing. I don't know how many people get an IM that says, hey, and then you wait, and they wait for you, and you say, hey, back, and you still don't know what it is they want, or how important it is, or when they want to reply by. So just ask. Say hey and just ask. Let gRPC help you out with that. So here's the other question. If I ask you, are you healthy, what do you reply back with? So what you think healthy is for your service might not be what I think healthy is for your service. You might say, no, I'm totally fine replying in 5 minutes. And I'm like, I expected you to come back in a second. Like, if you don't have a contract for that or you don't have some way you're talking about SLOs, that might not work. So rather than doing that, the recommendation we make is having to think about that set wait for ready, true or false. So what else can you do? I mean, this is the thing. Like, if this is a really expensive request, What's the nicest thing I can do for my clients that are trying to talk to me? So in a lot of cases, and it takes a while before we actually got into the role of doing this, is thinking about the life cycle of your tasks. So you have 100 tasks. Some of them are going to be going down. Some of them are going to be shutting down, moving to a different machine. Some of them are going to be getting updated. So there's change, there's constant churn in the system. So what kind of things can you do for this to avoid people having to inline health check you? So if you're going to start up, only accept connections once you can usefully respond. If there's nothing you can do if a critical backend is down, don't let people make connections to you. Don't make them have to health check you to see whether you can actually respond. If you can mitigate it and do a simpler, cheaper thing, great. But don't serve if it's actively dangerous to serve without something. So if you require some data, or you'll get sued if you don't do something, you need to make those decisions. So you need to be able to look and say, should I wait for ready or not? When you're serving, don't die. So if you have assertions in your code, just do them on startup. Like if you get a configuration that's never going to work, don't keep going. Don't keep going and then start up and say, actually, I can't talk to anything, I'm broken. Right? Because if you start to do an update and things come back up and they're broken, your update will continue, or you'll continue with someone doing the release that's causing the world to burn down around you, and you're like, whoa, 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 whoa. Right? So you can build it into your code, but make sure you do it on startup, not when you're serving. Once you start serving, try and stay up. Nothing gets worse if a task gets overloaded, that another task decides it's also going to shut down. If all of your tasks go, we're all not healthy, we're all going to turn off at the same time, you have a simple case of a global outage. You want to accept twice the normal load, and you want to degrade. And you want to shed or expire that early, so like we talked about, do something cheap if you're under pressure, if you don't have a lot of deadline left. So the greater component might not be healthy, but it could still be as broken as every other greeter you have, and you would like them to stay up and keep running. And when you shut down, this is where your deadline comes in again. If you have said, I'll respond back in an hour and something needs to shut down, you probably want to give it time to finish out that work. You don't want it to disappear. So think about the deadlines you set for, or what kind of agreement you've made with the people talking to you for setting a default deadline for your service. So degrade gracefully, we can do it. Load test, push it. Know where your limitations are, know what resources you're using up. Have a degrade it mode, 503s, whatever it is. Have some way that you can push back and let people know you're pushing back. When everything returns errors, fail fast. So that's the weird, fail faster. Don't wait for the deadline to run out. Okay, be cheap. Don't use least load it if you're being cheap, by the way. Those two things together will cause you a bad day. Know your critical dependencies, right? So know, every time you add a critical dependency to your system, you make it more brittle, you make it possible for things to break and go worse. Mitigate critical dependencies. So now we're into 5 of the 6 components, and I'll hand back to Gabe.
So Grainne has repeatedly said you need to measure something. The phrase is what gets measured gets fixed, to use that. The idiom is the squeaky wheel gets the grease. If you don't know what's hurting, you don't know where to put the Band-Aid. Yeah, that's a bit too sad. So there's a couple of questions we want to answer. We want to know what is happening. We want to ideally know why it's happening. Then we want to know who made it happen. And then, of course, will it keep happening? Is this an ongoing problem? Is this now over, or was this temporary? These are basically the 4 questions that we have about our system at any time. If we can answer all 4 of these, we know what it's doing and how it will be behaving later. For the what's happening thing, there are 2 general categories of metrics that we have. We have the server things. These are coarse, but they're absolute. If these things go bad, they're completely bad. These feed your capacity plans and your alerting. So the big ones, they're the obvious ones. They're your CPU, your network, your disk, your memory. If you run out of any of these, that's not good. That's the cost to run your service. These have limits. They have absolute limits. You need to know your use there, and you need to watch them over time. This is the least controversial part and sort of the most obvious thing. A thing that frequently gets forgotten is the startup time is also a per server thing. If you're serving from memory, that's quick, that's fast, that's fantastic, but first you might need to load your data set. That's fine. Your startup time, however, is your service recovery time after you've already fixed everything. Right? So your service is now fixed, but now you get to wait an extra couple of minutes while everything is loading its data set. That's okay. Know it. Know this and watch it over time. It will only ever go up in sort of history. Know it, watch it. And then on the right-hand side, we have the service things. These tell you like what is your service as a whole doing and how well is it doing it. This is where you compute your performance and compare it to your SLO so that you know whether it is good enough. Now, every service has some kind of good enough. If you don't know when it's good enough, you need to think about that. Or just turn it off. If nobody cares, then clearly it's cheaper. So the first thing is, of course, your request rate. That's your denominator for basically everything. Everything is fast per how many queries. Everything costs this much per how many queries. This is for your capacity planning. This is basically for everything. How many queries are you actually getting? You need to know whether you're replying successfully, of course. And that's nice, but remember that there is one way to succeed, but there are very many ways to fail. Right? In HTTP terms, a success is a 200, but a 404 is a kind of failure, a 500 is a different kind of failure. You care about different types. They indicate different things. Latency is probably important. Your service varies. Usually fast is better than slow. Your SLA tells you when it's fast enough, but only really when your success is fast enough, right? You don't care exactly how fast your failures are. They should be fast, as Grainne mentioned, but that's not really your SLO. Your latency is important, but you need to know, was this a successful query that succeeded in 2 milliseconds? It's probably good. Was this a failure that succeeded in 2 milliseconds? I actually don't care, it failed. I think that is often forgotten. Grainne just mentioned it in the logging. Sorry. I/O operations are expensive. Eventually, so is the space. If you're logging asynchronous, then while you're logging, you're not processing. While you're logging, you're not doing something.
Slide 50.
Are we doing a shortcut?
We're going a shortcut.
Okay.
So we're going to skip ahead. If you guys are interested in learning more about logging and all of the magic mystery things we do, you should come to our workshop later on today. We're going to go into our rapid fire round and then give you guys some chance for some questions. So our rapid fire round is our dynamic duo for best efforts. So these are the kind of things you'll hear people tell you. This is a best effort. This will definitely improve your service, but actually, will it work? So frequently given answers for how do I improve my service?
QoS, that makes everything go faster.
Caching makes everything go faster.
And it definitely won't take longer than some number of X.
Frequently missing question.
Oh, really?
Oh, really? Have you measured it? Do you have data to back it up? What does it look like? So,
QoS. QoS will probably make things faster, maybe make things faster. You can suffer priority inversion. You could just suffer poor utilization. You don't know it unless you measure it. Like in that picture with the standard and the fast track, maybe that's okay. Like maybe that single person in the standard queue there just takes a really long time. Maybe that long queue there, they have like season passes, they just walk in. I don't know, from the snapshot you can't tell, that's the point. You have to measure this, it's complicated. If you have some kind of reservation, you want a little bit for your batch traffic and most of it for interactive traffic, that's fine. What if your traffic mix doesn't do that? Are you wasting capacity? Next slide. Or are you using a profile where you sort of have a preferential thing so that if you have the space, you'll use it? That's great. Either way, that's fantastic. But on the left-hand picture there, now a burst of transactional requests, of interactive requests come in. Now they're suddenly queued behind the batch. Well, that's not what you wanted to achieve.
Caching makes it faster? So your old problem was it was too slow. Now your new problem is you have cache expiry to figure out what you want to do with. And then your other new problem is cache revalidation when you put in a new one. And then your completely unsolved problem when you add caching is negative caching. What do you want to do about that? So suddenly you've gone from it's too slow to 3 new problems. It may help, your mileage may vary, but you need to think about it.
So oh yeah, it won't take longer than X, some kind of time, right? gRPC gives you deadlines, but like not everything behaves that way. Some things don't even have an SLO, right? Not everything has a deadline. If you're querying DNS, right? Does your C library understand deadlines? Probably not. Do you understand all of your dependencies? Do you know when you're using DNS? Do you know how fast your disk is? Do you know what happens if your log buffer gets full? You're writing asynchronously, that's great. No, your buffer is full. Suddenly you're synchronous.
You should know what your mitigations are as well. So we've given you a number of different mitigations, but sometimes it requires paging a human, right? You want to make it as automated as possible, but you may still pull in a human. But you should have a plan. Whatever it is, you should have a plan for how you're going to mitigate things.
So QS may allow the well-behaved important things to go faster.
But it also needs careful management, and it may decrease your utilization.
Caching also may make things faster.
It may also make things more complicated and less correct, right? So eventually it may be consistent. But you don't want to give someone, hey, this is your balance for your bank account, but actually we forgot to tell you we took all this other money out of it, but we haven't processed that yet.
And then finally, it's not going to take longer than some amount of time.
Deadlines will help, but there's still system calls. They don't have deadlines. There's a lot of stuff your service is doing. There's parts of your service you don't control, like that translator. It could be doing other things at the back end. They may change how it's designed or what kind of features it's having developed, or they have a bad release. So in the end, we kind of call them our rules, but they're really our guidelines. And like, mostly just be considerate of the other systems and services you talk to and talk to you. Think about how you fit in that stack. And you are part of a stack whether you realize it or not. So it all boils down to be good neighbors. So what next? This is a place to send feedback. So if you're already using gRPC, you have features or other things you want to add, it's a good place to go. You still got questions? We're doing the workshop. We're in meeting room 9 upstairs. There's 20 slots. We'll be doing a lot of hands-on stuff and talking in more detail about a lot of the material we've covered here, so do join us. We're going to add some more of these examples to the grpc.io site, so you'll see some of the stuff pop up there. But if you got a question like right now, we'd like to go into Q&A and offer you a chance to ask us. So shoot.